Hello, welcome to my channel Qubit Educational Services. In this video we are going to solve the fourth question from the NEST 2020 first session. This question is based on number theory. For any natural number n, let f of n be defined as 3 times n plus 1 if n is odd and f of n equal to n by 2 if n is even. So this is a piecewise defined function. For odd n's it is 3n plus 1 and for even n's it is n by 2. Define f1 of n equal to fn and fi of n to be f of I minus 1 of n for I greater than 1. Okay, so we are defining composition of a function with itself. Okay, so f of f means f of f raised to 2 n. Now this is defined for I greater than 1, and suppose L is an even number greater than or equal to 2020. So we note that L is an even number and we are going to make use of this fact later. Okay, it is an even number greater than or equal to 2020, then the least value of I for which fi of 2 raised to L into 2 raised to L minus 1 upon 3 is 1 is 12 minus 1, 12 plus 2, 12 plus 1 upon and 12. Now we basically are required to find out how many times should we take the composition of f with itself, so that whenever we are having L to be an even number greater than or equal to 2020, 2 raised to L into 2 raised to L minus 1 upon 3 becomes 1. Now at first this question may look difficult, but trust me, it isn't. Okay, so here is how you should solve the problem. We first start with a theorem that, or a statement which is always true, that 3 always divides 4 raised to n minus 1 for any natural number n. Okay, now why is this true? We know that b raised to n minus a raised to n is always divisible by b minus a, and hence if we let b to be 4 and a to be 1, then 4 raised to n minus 1 will always be divisible by 3. You can prove this result by mathematical induction. Okay, now why is this result important as far as our problem is concerned? In our problem we are having the number 2 raised to L minus 1, isn't it? But there is another condition on L, that which is that L is an even number, which means if we take L to be an even number, then 2 raised to L becomes 4 raised to n if we write L as 2n, isn't it? And we know that 4 raised to n minus 1 is always divisible by 3. Okay, now we go to another part of the problem wherein we assume that 2 raised to L minus 1 upon 3 is k. Correct? Now note that 2 raised to L is always even, no matter what L is whether it is an odd number or an even number. Okay, because 2 raised to any power, any natural power, will always be even. So minus 1 will be odd, and 2 raised to L minus 1 upon 3, let us call it k, and the parity of k is important. K is odd now, because any odd number divided by another odd number is again odd, and because L is an even number, we can write it in the form 4 raised to n minus 1, which ensures that 2 raised to L minus 1 upon 3 is never going to be a fraction, it is always going to be an odd number. Okay, now by an adjustment we can write 3 into k plus 1 as 2 raised to L. Now this is another thing that we will make use of in our solution. Okay, we just note that if n is even, then, well, if n is odd, then f of n is 3n plus 1, and this expression that we have got here is similar to what is the definition of the problem, definition of the function if n is odd. Alright, now we apply the function on the given number, which is 2 raised to L into 2 raised to L minus 1 upon 3. Okay, now this is as good as applying f on 2 raised to L into k, where k is an odd number. Yes, now it really doesn't matter what k is or what parity k has, because 2 raised to L is there. It ensures that this number is always going to be an even number, and for even numbers, how are we defining the function? It is n by 2 which means if we apply f on the given number, it is going to give us the value 2 raised to L minus 1 2 raised to L minus 1 into k, which is essentially the given number divided by 2 because the number is even. Okay, now we have to apply this L times, isn't it? We have to apply it L times so that the index of 2 becomes 0. Okay, if we apply it once, then it becomes L minus 1. So we apply it L times. If we compose the function L times, then it is going to be 2 raised to L minus L or 2 raised to 0, which is 1 into k. And now composing f L times has led us to an odd number, which is k, isn't it? Now if k is odd, then what we do is we go back to this part of the definition of the function. We try to find f of n when n is odd. So what will f of k be? Will it not be 3k plus 1? Yes, and this 3k plus 1 is nothing but 2 raised to L. Okay, so that is going to be our next part. We had got f raised to L or f of that L times as k. Okay, so whenever we are finding f L plus 1, that means whenever we are composing it one more time, we will be applying the other definition of the function which applies to odd numbers, which will be 3k plus 1 because inside we have k. Alright, and which is 2 raised to L as we noted earlier in our solution, which means f of L plus 1 or f L plus 1 of the given number is 2 raised to L, and now we'll again follow the same process which we did initially. That means we will now be composing the function L times to reduce the power L to 0. So whenever 2 raised to L gets reduced to 2 raised to 0 or 1, we have effectively composed the function L plus 1 times, isn't it? For when we composed it L plus 1 times, then we had got k. Okay, when we composed it L times, we got k. We had to compose it one more time, then we got it as 2 raised to L using the definition of the function given in the problem. Now this has given us the result that we wanted. When f is composed 2L plus 1 times, and when we apply that composition to 2 raised to L into 2 raised to L minus 1 upon 3, where L is any even number, and in our case greater than or equal to 20, but that really doesn't matter. Okay, then we are getting the value of the function as 1, which means the minimum value of I that we should be calculating is 2L plus 1. Correct? So do we have this as the option? Yes, we do have it. It is option 3. So this was question 4. In our next video, we will solve question number 5 from IISc 2020 shift 1.